Okay, so now we're going to talk about modeling linear relationships. So we are going to actually read the separate card that you have that has an example of what's called logging on. It was kind of a longer word problem, so I made that separate, and then we'll go back and refer to it as we complete this lesson together. So Lenore has just purchased a tablet computer, and she is considering purchasing an access plan so that she can connect to the internet wirelessly from virtually anywhere in the world. One company offers an internet access plan so that when a person connects to the company's wireless network, the person is charged a fixed access fee for connecting, plus an amount for the number of minutes connected based upon a constant usage rate in dollars per minute. Lenore is considering the company's plan, but the company's advertisement does not state how much the fixed access fee for connecting is, nor does it state the usage rate. However, somewhere on the company's website, it says that a 10-minute session costs 40 cents, and a 20-minute session costs 70 cents, and a 30-minute session costs $1. So Lenore decides that she will use these pieces of information to determine both the fixed access fee for connecting and the usage rate. So Lenore makes a table of this information and a graph where the number of minutes is represented by the horizontal axis, or in other words, the X, and total session cost is represented by the vertical axis, or in other words, Y. So we're going to plot the three given points on the graph. These 3 points, when we graph them, we'll see what they look like. But first thing I want to make sure we go back and notice is that here it did say constant usage rate. So we want to make note of that up top here, that we have a constant usage rate. So that's constant rate. That's important. Okay. So we've taken what we were given. 10 cents a minute costs 40 cents, 20 minutes cost 70 cents, 30 minutes cost $1. And that gave us basically 3 coordinates, which have already been filled into the table. Okay, so we are going to go plot them on the graph because it says these 3 points, plot these 3 points on the graph. So I've got 10 and 40 cents. So that's about here. I've got 20 and 70 cents, which is about there. And then I've got 30 and $1, which is about there. So as you can see, these 3 points are appearing to lie on a line as I draw them. What information about the access plan suggests that the correct model is indeed linear? Well, it told us that the amount charged is based on a constant usage rate. And they said that constant usage rate was in dollars per minute. Okay, so in dollars per minute. So that constant rate is what's telling me that modeling it linearly would be a good idea. Now, I hope you notice about the graph that we're only working in quadrant 1. And we're working in quadrant 1 because we're talking about number of minutes and total cost. Both of those things should be positive, so we only require using the first quadrant of the graph. Okay, so then on question 2, it says the rate of change describes how the total cost changes with respect to time. You guys know rate of change, remember, going back to slope. So in A, when the number of minutes increases by 10, such as from 10 to 20, okay, or from 20 to 30, it was increasing by 10, okay, how much does the charge increase? So we're going to look at the table. When this went up 10, this went up from 40 cents to 70 cents, so it went up 30 cents. When it went from 20 to 30 and went up 10, this went up 30 cents. So for A, when the minutes increase by 10, the charge increases by 30 cents. So we write it with a $sign, 0.30, which remember is 30 cents. Okay. So now remember, she needs to figure out what that usage rate is and what the fee is. We don't know anything. We were just given these points. So now we can go ahead and move further and say another way to say this would be the usage charge per 10 minutes of use. So using that information to determine the increase in cost based on only 1 minute. So right now we know it's 30 cents per 10 minutes, but I need to know how much it is for just one. So we have to find the unit rate. So we want to find what it is for just one. So for 10 to become the one, we'd have to divide by 10. So we want to do the same thing on top. So 0.30 divided by 10 would be 0.03. So now I can see that we've got 0.03 or 3 cents per minute. So now we've finally figured out the usage rate. So then we'll go on to number 3, and it says the company's pricing plan states that usage rate is constant for any number of minutes connected to the internet. So using this information, determine the total cost for 40 minutes, 50 minutes, and 60 minutes of use. Record those values and plot the corresponding points on the graph in exercise 1. So we're going to go back to exercise 1, and we're going to beef up what we have here. So now that we know it's staying constant, I know as long as this keeps adding 10, which it does, I can continue to add the 30 cents on the other side. So that would make this $1.30. This would be $1.60. And this would be $1.90. So now I can plot those. 40, 130. It's about there. 50, 160. And then 60, 190, just below 2 there. Okay, so if I go back to question 3, we'll just put that this is in the table. Okay, now it says, using the table and the graph in exercise 1, compute the hypothetical cost for 0 minutes of use. What does that value represent in the context of the values that Lenore is trying to figure out? Okay, so first of all, let's talk about why they're rating hypothetical. Okay, if it's 0, that's connecting for nothing. So it's really technically impossible to connect for 0 minutes. Because then obviously you're just not connecting. But we still need to figure it out so that we can go and work towards finding the other piece of information that we needed. Okay, so we're going to go back to the table and take a look at it. So while the table was going up 10, the total session cost was going up 30 cents. So to go the opposite way, I'm going to make this one a little darker so that you're realizing this arrow is going different than all the other arrows. These were going this way, we're going opposite. When we were going down the table, we were adding 10. So to go back the table, we're going to subtract 10 to get to the 0. That's how we got there. So that means on this side, we have to follow the pattern that's being used on this side. While we were going down the table, we added 30 cents. So we're going to have to subtract the 30 cents here, which puts us at 10 cents. So going back to the question, we're going to put down that we want to follow the pattern of the table. Okay, we're going to follow that pattern that's in the table. And I now can see that it's 0.10 or 10 cents for 0 minutes. Now, using what you know from previous lessons and way back to chapter 4, if I now know what's across from 0 and I really wanted to plot it, it'd be right here. What is this thing called? That is what you used to know as your y-intercept, also known now in chapter 6 as an initial value or starting point. So we're going to write, this is the initial value, which means we have now found the fee. We now know what we have to pay for nothing. So that's the fee that I have to pay no matter what. So it says in number 5, on the graph in exercise 1, draw a line through the points representing 0 to 60 minutes. So we're going to do that. Okay, I'm going to grab a ruler. Now notice I'm not going to go past here because we're not going backwards, but we can continue to have more and more usage time. Okay, so we did that. And then it says the slope of this line is equal to the rate of change, which in this case is the usage rate. So if we go back and look at this, if I'm finding the slope, I'm going up 30 cents, but going to the right 10. But as you know from below, 30 cents over 10 ends up being 3 cents per minute. So that gives me my slope or my usage rate. So here we're just going to put on the graph. That's where you can find that. And again, your slope is this many for 10, which means it's 3 cents per minute. Okay. So now it says using X for the number of minutes and Y for total cost in dollars, write a function to model the linear relationship. So remember, this means write the equation in Y equals mx plus b form. So if I know it's Y equals mx plus b, I know that my slope is 3 cents a minute now. And we just found out that our initial value or fee is 10 cents. So now she knows how much she's going to get charged per minute and how much she's charged up front so that she can start deciding if that's the plan she wants to use. Now, we're going to bring in another plan though. She finds out there's another rate plan. So she's got a second wireless access company that has a similar method for computing its cost. Unlike the first company though, that Lenore was considering, the second company explicitly states its access fee is 15 cents and its usage rate is 4 cents per minute. So that means your total session cost is going to be your 15 cents for your fee and your 4 cents times the number of minutes that you use. So using X will represent the number of minutes used and Y represent the total session cost. We're going to construct a linear function that models the total session cost based on the number of minutes used. So again, this is just another way of saying write the equation, and we're using Y equals mx plus b form. Okay, so we know our total cost is Y. And then we've got either way you want to write it. You can write it as the fee first, which is your y-intercept or initial value, then your rate of change or your slope, and then X is the number of minutes. Or if you prefer it to be literally in mx plus b form, you would write Y equals 0.04x plus 0.15. It doesn't matter which way you write it. So now in 8, using the linear function constructed in exercise 7, so the one we just wrote, we're going to determine the total session costs for sessions of 0, 10, 20, 30, 40, 50, and 60 minutes. And we're going to fill these values in the table below. So remember, this is just regular old substitution. So if I want to know how much it is for 0, I would do Y equals 0.15 plus 0.04, but I would replace X with 0, and then I would use my calculator to figure out that math. Okay, so this would be Y equals 0.15 plus 0. So Y is 0.15. So now I know I'm writing 0.15 in this spot, which makes sense. You should be able to fill that in anyways because it's our initial fee and initial value of what should be across from 0. So now if I want to know what it is for 10, I'll do another example down here. I would have Y equals 0.15 plus 0.04 times 10. So that means that 0.15 plus 0.4, which means this is 0.55, 55 cents. And we would continue going in that pattern, or we could recognize that while this goes up 10, this is going from 15 cents to 55 cents, which means it's going up 40, which makes sense because if you look at our equation, it was going up 4 cents per minute, so it would go up 40 every 10 minutes. So now we can just use that to populate the rest of the table. So we've got 0.95, we've got $1.35, $1.75, $2.15, and $2.55. So now in number 9, they want us to plot these points on the original graph in exercise 1. So what I've done is copied it for you over here, so you don't have to keep looking back, and it's already here. And draw a line through these points, and then we're going to take a look at a comparison here. So this, I want to make sure we know, is the first company before we plot the second one. Okay, so our second one, we've got 0 and about 15. So it's a little higher because remember before it was 10 cents. And then we've got 10 with 55, so just barely over 0.5. We've got 20 with 95 cents, so just under $1. 30s with $1.35, just about there. 40 is with $1.75, so it's halfway between. 50 is with $2.15, so about there. And 60 is with $2.55, so just above 2.55. Now, technically, this should be extended. And then we will connect our new points. And this is the second company. Because now we have 2 on the same grid. We want to make sure we know which is which. So the next part says, in what ways does the line that represents the second company's access plan differ from the line that represented the first company's access plan? Okay, so let's look at this first. This one started at 10 cents. This one starts at 15. So the second company starts at a greater initial value. So we're looking at the 15 cents versus 10 cents. Okay, and if you look at it, it's a little steeper than this one. So it also increases in total cost more quickly over time, which means that the second company slope is steeper. Okay, so again, second company starts at a greater initial value, which means it has a higher fee. And the other one is also increasing. Second one is also increasing more quickly, which means it has a steeper or greater slope. So you might even want to write that greater slope, add that to it if it will help. Okay. So now that we've gone through one together, I want you to go through and try a practice problem. It has parts A, B, C, and D. A band will be paid a flat fee for playing a concert. Additionally, the band will receive a fixed amount for every ticket sold. If 40 tickets are sold, the band will be paid $200. If 70 tickets are sold, the band will be paid $260. Go through and try parts A through D. At this time, you're going to pause the video, try those problems, and then you can resume the video to check. You might even want to consider doing a part at a time. So try part A, watch the video, pause the video and try part B, watch B. It's up to you how you proceed. Okay, so at this point, you should have tried point A. It says determine the rate of change. Now remember, rate of change is the same thing as slope. We need to find the slope. They did not give us the rate in here, but what they did give us is coordinates. We have 40 tickets sold will be 200 and 70 tickets sold will be 260. So they give us coordinates. So gives coordinates. So we've got 40 and 200. And we've got 70 and 260. So it's a lot like the first company that Lenore dealt with. She had no information about the rate and fee, but she was given coordinates or values. Okay, so we're going to have to use our slope formula here because we don't have rise over run in a graph. So there's our slope formula. Here's x from the first and y from the first. Here's x from the second and y from the second. So we're going to plug them in. So y2 is 260. Y1 is 200. X2 is 70. And x1 is 40. So 260 subtract 200 would give us 60. 70 subtract 40 would be 30. 60 divided by 30 would be 2. So we know that the rate of change or slope is 2. Part B. Let X represent the number of tickets sold and Y represent the amount the band will be paid. Construct a linear function to represent the relationship between the number of tickets sold and the amount the band will be played. So construct a linear function, remember, just means to write the equation in y equals mx plus b form. So I need m and I need b. Right now, I already have m. What I don't know is b. So now you're going back to chapter 4 again, where how do you find the y-intercept when you have the slope and you need to find b? Well, we have the slope, but we also have a point. We can pick one of these points. So I'll pick 4,200. That's going to be my x and my y. I know my m is 2. I'm finding my b. So if y equals mx plus b, y is 200, m is 2, and x is 40. So 200 equals 80 plus b. I will subtract 80 and get 120 is equal to b. So now I know my equation is y equals, my slope is 2, and my y-intercept is 120. So there's the equation that represents this situation. So now in C, what is the fee the band will be paid for playing the concert, not including the ticket sales? So remember, the fee is going to be your starting value. So the fee is $120, and I can very easily tell that because it's just the same thing as the y-intercept, or what we now call initial value, which is the same thing. And then how much will the band receive for each ticket sold? That's your slope. So they receive, the slope was 2, so that's $2 per ticket. Let's get a different pencil here. $2 per ticket, which is your slope. And that concludes our lesson for modeling linear relationships.